Well, hello students, this is Coach Holliday, and today we're talking about functions. It's a continuation of our lesson on relations from yesterday. Go ahead and take your note packet out, and let's get started. Before we get going though, make sure that you remember that if you didn't understand something as I go through this, go ahead and hit the pause and rewind and go back and cover that again, okay? Here we go. What is a function? A function is basically a relation, which we talked about yesterday. Remember, a relation is just a set of ordered pairs with x values, which are called the domain, and y values, which are called the range. Remember, we talked about that yesterday, okay? We want to think of a function as a machine where you're putting something into it and something comes out of it. All right, so what I'm going to do is I have my domain. These are my x values, and I'm going to plug these into the machine, and the machine is going to do something with it. It's going to take that x and it's going to multiply it by 2 and then add 3. So let's start with our first x value, which is -1. If I take that -1 and put it into the function and plug it right there, that gives me 2 times -1 plus 3. And when I do that math, that gives me +1. So my first order pair is going to have -1 for the x, the domain, and +1 for the y. Easy as that, okay? All right, let's do our second one. Our second one is 0. Our second domain value is 0. Plug that in for the x and get 2 times 0 plus 3. When I do the math for that, I get 3. So my second order pair is 0 and 3, if I did that math correct. And then our third order pair, let's do that one. Find that one. So we're going to play our third domain value, plug in 1 into my function rule, and I have 2 times +1 plus 3. When I do the math, that's going to equal 5. So my third ordered pair in my function is going to be 1, 5. Okay? So that's basically how I find it. And I didn't write the range down here, so let's go ahead and write the range. The range would be 1. Remember, we typically write these in least to greatest order. 1, 3, and 5. Dang it, I can't get that 5 to stay there. All right. Hope you didn't have any questions on that. If you did, you can ask them tomorrow in class, okay? Now we're going to talk about something called function notation. Function notation is actually pretty simple, although it seems like it's kind of confusing. But function notation, I'm going to write in that form. And that's said f of x is how we say that. So repeat that with me. F of x. F of x, okay? Well, all f of x means is the same thing as y equals. So f of x and y mean the same thing, okay? So that should be easy for you, okay? We use f of x just to show that the equation represents a function, all right? So since the equation y equals 2x plus 3 is a function, we can instead use f of x equals 2x plus 3. You notice all I did was change the y to an f of x, okay? Now, if you'll notice, in that statement, f of x, it has an x there, all right? If I replace that x with a value like -1, all we do is we substitute, fix my pen, substitute that -1 in for the x there. So I substituted in for the x there. All right, so what I would have is I start with f of x equals 2x plus 3, and I take that -1 and plug it in, so I have f of -1 equals, now I'm going to put -1 where the x is. So f of -1, when I do the math on the right side, equals -2 plus 3, which is just going to be 1. Okay? So it's just another way of doing what we did on the page before, all right? Back in the first, with the function machine, okay? So let's do a couple of examples. So my first example is going to be f of x equals x minus 3 when the domain is negative 2, 0, 2, and 4. So remember, domain values, those are my x values I'm going to plug in. So I'm going to take negative 2 and I'm going to plug it in for x. So I'm going to find f of negative 2. That's going to equal negative 2. Make sure when we write this we put them in parentheses. Negative 2 squared minus 3. Now negative 2 squared just means negative 2 times negative 2, which is 4. 4 minus 3 is 1. So that's going to be my range value. So my range, my first one, is going to be 1. Similarly, I'm going to do the same thing for 0, 2, and 4. Okay, so what I would like for you to do is I'd like for you to just take just a moment and go ahead and substitute those 0, 2, and 4 and see what you get. Okay, so hopefully you got that f of 0 gives you negative 3, f of 2 gives you 1, and f of 4 gives you 13. Okay? All right, let's go ahead and work this in the next problem, in example 2. In example 2, I give you f of x, I give you a g of x. G of x is the same thing as f of x, it's just a different function, okay? So when I see an f in the problem, I'm going to use the f of x. Okay, so that would be right here. I'm going to use that f of x. When I see g in the problem, like in B, I'm going to use the g of x and use the g of x for that one, okay? So let's go ahead and try one here real quick. Get my pen where I want it. Alright, so f of negative 3, I'm going to use the f of x. So I'm going to do f of negative 3 equals negative 3 square it plus 4. Okay, so hopefully you got a chance to figure that out. G of negative 5, I use the g of x function. Do 5 minus 3 times negative 5. I plug in my negative 5 right in where the x was, and then I do the work. I got to do negative 3 times negative 5 is 15, and then plus the 5 is 20. F of 1, I plug in a 1 into the f of x function, so I get 1 squared plus 4 times 1, which is 5. And I got to add to that g of 3. When I do that, g of 3 is 5 minus 9, which is negative 4. So I get negative 4. 5 plus negative 4 gives us positive 1. Okay? Hopefully that made sense to you. Alright, let's go ahead and do one more example, and then we're going to get you started on your get you finished up for the evening. Okay, this example puts together all the parts from yesterday and today. Okay? So you're going to use the graph to answer the questions below. List the order of pairs, list the domain, the range, is it a function, why or why not, and then find f of 2, f of negative 3, and f of x, find x when f of x equals 7. Now remember, f of x down here, that just means what is x when y equals 7. So find the order pair that has 7 for a while, okay? So give this a try, see if you can go through and do it, and then I'll give you an explanation. We'll start the video when you're done. Okay. Are you ready to get started? Let's go ahead and get started again. Okay. List the order pairs. Go ahead and look at those order pairs. Negative 3, 4, negative 2, negative 5, 0, 7, 2, 0, 4, 2, 4, negative 6, and 9, 5. Okay? The domain is just all of those x values, and I put them from least to greatest. The range is all those y values, and again, I put it from least to greatest. Is it a function? It's not a function because if you'll notice, when x is 4, y is 2, or y is 6. So remember from yesterday's lesson, it's a function only if each x has exactly one y with it. Okay? When I look at f of 2, I go when x is 2. Here's where x is 2, right here. What's the y value? It's 0. When x is negative 3, the y value is 4. When y is 7, when y is 7, x is 0. Okay, so that's using it off the graph. Okay, all right, great. I hope this answers questions. If you had any other questions, go ahead and rewind and redo some of the notes. And also, if you would go ahead and complete the WSQ document, have that ready, get that turned in, and so we can go over that at the beginning of class. Make sure you answer it and leave any comments or questions that you have on that. Okay, have a great evening. We'll see